Hi, and welcome to Office Hours with Amber. I'm Amber, and this is Office Hours. I adjusted a few settings on my OBS, and I have very little belief that it's working properly. So if you see wonky stuff throughout the stream, this is the last week, maybe second to last week, of me complaining about the stream quality, because I am building myself a PC. Now, it's going to be real embarrassing if I went through all of the trouble to build a PC and to find out it was like an internet issue or something. But I did check, and I've got like a 22 megabits per second or whatever upload speed. So it doesn't seem like it's the Ethernet internet situation. We're going to find out. But this is, I've been putting off this month. I'm glad I put off this month until now, because lambdas scare me, and they shouldn't. It's a formula. Like, Amber, let's get so real. But yeah, so last month was the let function in Excel. This month is the lambdas function, and I have put it off for so long, and I'm not going to put it off any longer. And last month was a really good gateway into lambdas, because there are so many good lambda dynamic array functions. And also the project I'm working on, like every time ChatGPT and I really have a moment together, it's like, you know, let's cool, but lambda's cooler. And I'm like, I know, we all know. So I'm going to be so real with you. My understanding of lambdas is like pretty much zero. I know it's super cool. You can make it as a named brain like you can make it like a dynamic named. You know what? I'm not even going to pretend with you. I know they could do really cool things. That's in totality. To delay a little longer, updates on my life. Yes, one, I'm building my own PC, so the stream quality is going to improve. Super stoked about it. Two, I just want a little shout out for my niece. Okay, so she's turning 9. She had her birthday party this weekend, and she's a businesswoman. She's building an empire already. Let me set the stage. So it was a fairy themed birthday party, and some of the events she planned was palm energy readings, and based on what your palms look like, you get assigned a certain energy. She's a great storyteller. Then there was, and after you do that, you get your flower crown in your ears. After that, you do a fairy obstacle course, which they even painted these like little goblin troll things. So cute. Once you do the obstacle course, you get your wings, and the wings are so cute. All these little 9-year-old girls running around with their wings in their ears. So fun. But before all of that, before she even got to her party, she made all of her friends sign contracts. This 9-year-old girl, let's cut in close. This 9-year-old girl drafted up contracts by hand. Also, my acne is so bad right now. Whatever. This 9-year-old girl drafted up contracts and says, I blank will not throw a fit if I get a energy reading that I don't like. She's managing expectations. So this girl, we get to one day before. Okay, let's relax. That's so much acne. Okay. We get to the day before her birthday party, and I'm asking her, what's the plan? What are we doing? She's like, we need an agenda. And I'm like, okay. So she's writing it out, and she's getting a little frustrated with, some spelling stuff. I was like, let me write. So I'm scribing her plan. And so she's like, 11, grandma's going to make lunch. 12, we're going to decorate for 1 hour. 1, we are going to get so slay, which means we're going to get cute, which I thought was so fun. Anyways, so that's all good and fun. So we make this whole itinerary, and then it gets to the next day. Cutting back in. This girl, oh my God, the acne is so bad. Yeah, back out of that. Anyways, the next day, it's 11 a.m. and my niece goes, oh, Grandma, it's time for lunch. Sorry, it's on the itinerary. Contract, expectation management, project management. This girl is, thank you so much. This girl is going places. I've never been, I would have been proud of her either way. She's so cute and hilarious. But the fact that she's got all these like underscore of business skills just makes me happy. First of all, who showed her a contract? Second of all, she also made a physical PowerPoint, like a whole documentation. Like she was like presenting to me the birthday party plans. I was like, oh my gosh. So when she gets of age, as in old enough to want a computer and want to learn, that girl's getting PowerPoint and Microsoft Word, and we're going to go off. So anyways, okay, I've stalled enough. I'm really excited about LAMBDAs, and I know they're going to be really helpful. I'm just really scared. So we're going to watch some videos. The stream might get choppy. That's just the way she goes. But next week, hopefully, we will have... I'm just stalling. I really don't want to do this. I'm going to do it. Okay. Let's do it. It's going to be fine. Let's start with our girl Layla. Let's start there. Oh, and it seems like LAMBDA is a function that is used in other forms of coding. So we're just going to go LAMBDAs Excel. And hopefully there's a Mark Proctor video because I love him. Lots of good choices. Lots of good choices. Harry, how are we doing? How was your night? Ooh. Okay, we already did let. Maybe, you know what? Okay, we're going to start with also, I was beefing with ChatGPT earlier on trying to get my frames missed figured out, which it seems like the frames are doing okay. So y'all let me know. Okay. Let's start with ChatGPT. You hit your head while ice skating? Oh my gosh. That's so scary. Okay, we're going to start with, I'm nervous to learn about LAMBDAs. Ask me a few questions that will help me learn about them. Also, we've got the In My 30s Era cup. Ooh. Ooh, okay. Last questions. Whenever it gives me more than 5, I'm like, can we relax? What kind of things do you build often? Have you ever used let, filter, sequence? And do you prefer concept first or example first? Ooh, okay. 1. KPI creation, process engineering, data cleaning, data manipulation. 2, yes, very familiar with let, which honestly, let has simplified a lot of functions this month. So we love her. like a mix of both. Okay. While that cooks, I'm going to watch this video with
At
Layla.
first, I thought it's a nice to have, and then I saw recursive lambdas. It changed everything. Now, I'm not going to talk so much because you need to see this. Now, this is going to blow your mind. In this example, we have a list of names and the skills of each person. Now, unfortunately, we have mistakes here because some people put in Office 365 where they should have put in Microsoft 365 instead, or PowerPoint with a space where it should be PowerPoint. So here we have a list of before and after, and we want to get these corrected. So notice that some of them are going to require...
Oh, you better believe, Harry, that I am the master manipulator. That is 100%.
multiple corrections because they have made mistakes for every single skill. What we want to do is go to each cell and loop it through the before. Whenever it comes across a match, it should take the after version of it, make the replacement, and put it through this list again. So it's similar to a for next or a do while in VBA. We're going to do this.
Ooh. Oh my gosh. Oh. I've been living in logical operator land for so long, like if, and, or, whatever. I have forgotten about do whiles and loops and for next. Oh my gosh. For context, I started my college career a decade ago in computer science. This is dusting off. And it's like an old friend. This is what it feels like. Oh, I'm excited. And this is going to become really important for what the data I'm working with right now. I'm still stalling every step of the way. Okay, we're good. We're good. We're back in it. I'm excited.
This with a formula. Check this out. I've already written the lambda for this. My function is called mega replace. So the moment I start to type it, it shows up here. It needs the text that I want to replace. Then it also needs the start of my before table and the start of the after one. Now I'm going to fix these because this is a table, and the moment I press enter right here beside the table, it's going to add this as a part of the table. Now when I do this, press enter, take a look at what's going to happen. Everything is replaced. Okay.
Did you guys hear that? Wait.
Table, it's going to add this as a part of the table. Now when I do this, press enter, take a look at what's going to happen. Everything.
Can I put buttons on here? I want a button that goes wow at me. Oh my gosh, wait, one more time.
Now when I do this, press enter, take a look at what's going to happen. Everything is...
I completely forgot I was live just now. I think I'm in a state of full crash out. I was reading the chat and I was like, doo, 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 and then all of me just went blank. I'm excited to watch that back because what the fuck? Okay. First thing to understand is functions. Forget about the scary lambda word. What is a function to you? Oh my gosh, Bridget. Yes, thank you so much. I do need a soundboard. I need to Google how to do that. I mean, I feel like I know what is function. Is this a trick question? Okay, I'm being dumb. Okay.
Look at this. Office 365, PowerPoint, Microsoft 365, PowerPoint written correctly. The one where we had a lot of mistakes, that was this one, for example, it's all corrected. This is an example of a recursive lambda. Now we're going to get to the engine of lambdas in a second, but let me show you a practical example of a lambda that's not recursive. So let's say in your workbook, you generally need to do a certain task, which is to sort certain fields by the sum of another field in descending order. So for example, you want to sort department by the sum of salary. Kind of like doing a SUMIFS on your salaries by department and then sorting them just by department. Because notice that the sales department is repeated here. So are the other departments. Now you can create a lambda for this so that all you have to do is type in your own custom function. I called mine sort by sum. This one just needs 2 arguments, the column that you want to sort up. Well, let's cover the basics of
Okay.
lambdas right
I think
here.
this is where I need to be.
What are lambdas to begin with? These are just functions that you create. These functions act like machines. Once you've created that machine, you can put through it other ingredients and reuse it as often as you want. This means that you don't have to recreate the machine every time. So let's do an example here. Let's say I have this list of prices and I want to calculate a 30% discount rate. So what would be the price after a 30% discount? To do that with a formula, I just go B4 multiplied with 1 minus 30%, close bracket, and press enter. If this is a formula that I'm using a lot, I could turn it into a machine. This way, I can reuse it with other similar ingredients. So how would this look as a lambda? Well, the great thing about creating your machine with lambdas is that you can create it directly in your formula bar. It's a function. So I'd start with typing in lambda, and then you need parameter or calculation. So basically, each argument is either a parameter or a calculation. Well, anywhere you see cell references, these are going to become your parameters. So here I'm just referencing B4. B4 is going to be a parameter, and you can call this parameter anything you want. Now, I'm not really creative with names, and I don't like to waste time thinking of good names, so I usually just go with ABCD or XYZ. So I'm going to call the parameter B4, which is my cell reference, A. This is my calculation, and I have to mention the parameter at the beginning. So it's A, comma, so then I go to the next argument, and it's always that the last argument of your lambda is your calculation. Anything before are your parameters. Now I've created my machine. I need to close the bracket to close the lambda function. So what happens when I press enter? Well, before I do that, just take a look to see if you're subscribed to this channel. If you aren't yet, consider subscribing. Let's take a look. When I press enter, I get an error. Why? Because I've just created the machine, but I'm not putting anything through it. I need to put in an ingredient in there. To test your machine on the grid here, you can do it by putting in a cell reference. To do that, at the end of your lambda function, open the bracket and do a cell reference. That's going to act like your parameter. So since I only have one parameter, this B4 is going to become A, and it's going to get put through my machine. Now when I press enter, I get what I got back before. Now obviously, this formula right now is not so useful. It's better just to have what I had before. The advantage of machines like this, like the lambda function, is that you can give this a name, and then you can reference this anywhere on the grid. And we're going to see this in a second, but I want to show you a lambda that has 2 parameters. So let's say instead of 30%, you want this to be dynamic as well. So you can turn it into a parameter. I'm going to call this one B. Now, because this machine needs 2 ingredients, A and B, I have to have them as parameters on the side here. So it's A, comma, B, comma, and last is my calculation. Okay, now what's going to happen when I press enter? Let's check it out. It's not going to work. Why doesn't it work? Well, the machine needs A and B to work. I've only given it one thing. I've only given it A. So what is B? Well, it's 30%. So you can either do a cell reference or directly type it in. Now when I pull this down or send this down, I get the same results. Okay, so how can I turn this into a name that I can reuse? Well, once you test that your lambda works on the grid, you can copy it. Actually, let's copy the equals as well.
I think I'm doing something silly. Oh, it has to be inside of the comma. Duh. Okay, fine. I think this is going to be a scenario where I have to watch 100 million example videos, and then eventually it'll turn into like oh, fantastic, Matt. I should play this panda song. Okay, I'm gonna keep thinking.
So you just copy the machine part of it, and then you go to name manager. So under formulas, name manager, you create a new name. You can call this anything you want. I'll do calc discount, and then paste in my machine in here, and okay. Now, whenever you use more than one parameter, I recommend you add in the comment what each parameter is used for. So something like A equals your value, and B equals your discount, and okay. Okay, so now...
Oh. stand by. I'll be back. Hello everyone. I'm back. We don't need to talk about what that was, but we're so back. So let's do it. Okay, we're now at the part where I'm putting in the name manager, which I do love. I'm interested eventually to see the recursive side of this. Sometimes my brain kind of gets wrapped up on itself though when I try to do that. But we're gonna do it. We're gonna conquer our fears, and I'm gonna do it. Calc discount. Calc discount. Equals okay, what else does she say?
And one parameter, I recommend you add in the comment what each parameter is used for. So something like A equals your value and B equals your discount. And okay, so now we have this as a lambda. This means that whenever we need to call this, all we have to do is type in the name of our function, which was count discount, and it needed two things, which was this and our discount rate. Now I'm just going to put the discount rate here.
Oh.
Let's fix it. Close bracket %. I have nothing, so it's 30. If I put 20%, now I have a 20% discount.
Fantastic.
This is something I can reuse anywhere in my file. Now let's see.
I'm embarrassed. I know, like, lambdas really haven't been, like, there was nothing scary about that. And I knew, here's the thing. I knew lambdas were not going to be as hard as I thought they were. But I had to, because of the level of creative sandboxery that you can do with lambdas, it was necessary to take the steps I did to get here. So dynamic arrays plus let plus lambda is going to be hypercritical to add those three all up together to do really, really, really beautiful lambda, like use it very properly. So I'm not shaming myself for waiting this long to do it. However, we were one video away from unlocking a whole section of the brain, so I'm upset with myself. We're past it.
Take a look at the practical lambda I showed you before. How can we create that? Well, the first step to creating lambdas is to try it out on the grid. This works for lambdas that aren't recursive. All you have to do is figure out the function you need first, then turn it into a machine, basically a lambda, and then give it a name in Name Manager so you can reuse that machine anywhere you want. In this case, we want to sort any column that we want by the sum of another column. So here, for example, I want to either sort the department or sort the position in descending order based on the sum of salary. So I'm going to pick position as my guinea pig. I'll try to write out the function that works, and then I'm going to turn it into a lambda. So I'll start from the inside of the function and work outwards. I need the SUMIFS function. The sum.
Okay, let me skip along here.
Here, I have to replace it with my parameters. So this is going to become my A because C4 to C19 are my labels. That's going to be A. I'm going to replace.
I think I see where let's could be helpful, because really let's become your variable declaration.
This also with A and this A as well. D4 to D19, that's going to become my number parameters. I'm going to change it to num. Now I can quickly add A.
Okay, let's do let and lambda. I think so. Okay, I'm not gonna get overwhelmed. It's not that hard. Okay, let's look at Beckett, see what ChatGPT had to say. Okay, so I gave it kind of the vibes. Why lambda matters to me. I already write clever formulas. Oh my gosh, you saucy girl. We can name, recycle, make them readable, which we love, because let was a very good stepping stone into that. Easier to debug, which is so true. Okay, a moment, some commotion for let statements. That being able to assess, I think Emily said it so well, like being able to read your equations in English. Fantastic. Oh, we got a little bit of, oh, beautiful. Wrong way. Uh-oh. Okay, vibes. Anyways, I never took the Ritalin. Cracked again. Okay, anyways, let, fantastic. I think, oh, I'm full ass having a stroke today. My brain is fried. Oh, happy Cinco de Mayo, everyone, for those who celebrate. But yes, let's, lambdas, readability, especially being able to work with like clients and being able to like read it verbatim, be like, you don't need to know what the cell references are. Revenue minus expenses equals profit, probably. Okay. If statement, if before I do some stuff. Instead, you could define it as a lambda. That's fine. In discrete event simulation and creative uses. Okay, so I'm working on a project about simulation, so I want to see what its ideas about creative uses of lets and lambdas might be. Reusable time logic. Sure. Time in system. That's fine. Data cleaning. Sure. Custom distribution. Vibes. I do like the distribution generator would be nice. Would be nice. Agent assignment. That would be interesting. But I already do that in Power Query. That's fine. That's fine. That's fine. Let's just bop around and see what happens. Oh, Mark Proctor, always. Oh, Dim, obviously. Why would I not watch his? Fantastic.
Today I want to talk to you about the two most powerful functions in modern Excel, which are let and lambda. I've made a bunch of different videos where I use lets and lambdas before, and some where I've tried to talk about motivations for them. But today I want to kind of dive in a little more in detail to, if you're a person who has, a spreadsheet with some complicated workings to figure some particular. So this is a case based on a game of table soccer. So the idea of big Excel formula is a bad name is to say, okay, this points to M96. Let me just grab the formula from M96, and I'll put that in there, and then, and then this points to N96. So let me just grab the formula from there, put that in. If I keep repeating this process, I end up with this formula. So this is doing all the same as those things. Slight difference that I've done. Instead of having a text split here, I've just split it into a text before and a text after. But it's doing all the same things, but it is very hard to read what this formula
Ain't that the truth, brother?
in field control, what I'm looking for is look up this player's row, and then subtract off it. It's just like reading through it is complicated. And if you build big Excel formulas like this, your Excel formulas will be hard to read, hard to audit. Everybody will be scared of them.
True.
There is a different way of converting all of this into one cell in a way that is much more readable, and that's using let. And let is basically a function that lets you that allows you to define a series of variable names, just exactly like the way I would think of it is, here I'm defining one variable as this, here I'm defining another variable as this, and just like these things can refer to earlier cells, in let your definitions can refer to earlier definitions. So here's that whole thing converted into a let. So
I'm not secretly, none of this is a secret. With lets, I have been getting more comfortable because your brain naturally is like step 1, step 2, step 3, step 4. But if you're really going step 1 through 4, let's just have a kiki. If we're doing step 1 through 4 in sequential order, most of the times that's like, it's good, but not great. Like, it's not a great use of let. Like, there's a lot of great uses of let. Do not get me wrong. But I like when let, you can build the previous logic. So something like, if you're reusing logical information multiple times. So let's say A equals an if statement of if this is greater than 0, profit. If this is less than 0, not profit. I don't know. And then B has a different logic and C has a different logic. And then comparing, and then your final formula is comparing all three of those things. But there's also steps where you could do, and I'm not explaining this well at all, but eventually this is me understanding my own logic. Okay. You could do 2 or 3 lines of logic off of one set of information, 2 or 3 lines of logic on something else, and 2 or 3 lines of logic on something else, and then one final. You don't even have to, technically in your output calculation, you don't even have to reference any of the stuff that you just created. So we're talking about lambdas. I'm going back to lets. It's comfy. Anyways, what I'm saying is I've been exploring and really pushing myself to do more creative uses of let that are not so sequential, logical, in order. Ice picking at a mountain. You know what I mean? What am I talking about? More like I don't even know how to describe it. Like, for instance, you see how his first, he's got 2 different Let's make this full screen. Okay, so you can see like the first row is like PL row and PL column. They don't reference each other or even play off of each other at all. Even number 3, like the first 4 rows don't even interact with each other. And I think original Amber, when she started using lets, thought that each previous row had to reference, like each row of logic had to reference the one before it, which is silly because nobody ever said that. But I think because of the way that Power Query interacts, and the first time I saw lets is really back in Power Query land, because if you are a button clicker in Power Query, so for instance, we've got this data down here. We're taking a very sharp left turn here, but I'm just explaining the logic. So we've got this data from a table. We'll see if my computer, come on, this is very easy stuff, guys. Guys as in computer. I'm so excited for my PC. It's going to be wicked. Okay, let's say in this, we want to filter on a few things. And then we want to we'll pivot a column, transform, pivot column. Oops. Just doing something random. Okay. So when you look at the advanced editor of this, what you'll see is source and then like let equal source equal this stuff. Variable, variables declared. Next row, filtered rows, new variable equals function, but you can see inside of here, source is called. Next row, a variable, pivoted column equals, and is declared as this shit over here. And you can see that filtered rows, it's taking all the data that is experienced back here, and then it's doing like basically the ending statement is I want it to display this thing. What I didn't realize, so if you are a button clicker in Power Query, which I was, that's where I learned that, or that's where I thought that every row had to reference the previous row. But even when I was watching Melissa DeCorta and Shandeep's Power Query videos, that's where they were saying you can do anything you can make M code reference all sorts of stuff from all sorts of different places and then bring it together in different steps. And I'm unlearning the behavior of thinking that it all had to be sequential. Yeah. That was a long story just to say I'm unlearning bad behaviors.
Be this here, which is R1. Let the vector be this, which is this cell. And then the player row, we're just going to X look up the starting player in player and row. So this formula here is exactly the same as the formula in this cell, except that we've replaced the cell reference with start player. And we just define start player up here. And then same thing here. This formula is exactly the same as the formula here. This formula and this formula are exactly the same as the formulas here and here. And then these ones are exactly, and so on. So it's mirroring exactly what's going on over here, but two things. One is it's all happening in one cell, and the second thing is you've got this sort of natural documentation. If you have, reasonably readable, you don't want super long variable names because then your formula becomes enormous. But here it's easy to read this as like player row, player column, offset row, offset column, destination row, destination column, and then next player. And hence it's column 4 when you're doing a piece. And then up and copy down, and that works nicely. But now we've got an enormous complicated formula in every cell. So the nice thing to go from here is that you can then define, you can convert this into a custom function that takes a given starting player and a given vector, does all these workings to it, and ends you up with the next player. So how do you do that? Well, the function that makes functions in Excel is lambda. And the idea is you tell lambda, I'm going to have 2 inputs. That's going to be start player and vector. And then after whatever number of inputs you have, the next thing you put, which is going to be all of this, is what you do with those. So that's the setup for the lambda. And then here, I'm just going to take these first 2 definitions out, because the idea is I will later feed this a value for start player and a value for vector. So I want to take those definitions out. And by the way, setting your sorry, so that setting your let up like this, where you have all your external references or constants or anything else at the start. A is great because, you know, I don't need to look down here if I need to change references. I can just change it in the first row. But B, it also is a very natural setup to turn it into a lambda, because then you can just take out the first couple of definitions, make those variables for your lambda, remove them from here, and then you're golden. So that's the lambda. If you put it into a cell, it will just give you calc, because it's a formula without any arguments. But then let's say we give it an argument R1 and an argument of this vector. It drops out. Sorry, I still have offset row here, so I'm returning the offset row, but I need to return next player. So now it outputs R8. But this
Other thing, cool thing is the how to describe what is going on in my head right now. I have had I think I tried to do this last time, but if you've got a let statement or a lambda that's calculating all sorts of different things, and like you saw there, the last part of the let is just what the output is, and it's whatever step the variable that was declared earlier on. If you put that as your output calculation, or your, you know, the last bit of it, it'll display whatever that step or that variable was, which is nice because then you can build one really nicely done let and output 5, 6, 7, 800 things that is a quick toggle to get those different analytics. I don't think that you can make the output parameter, what is that even called? Output. It's got a better name than what I'm calling it.
take all of this.
It's got a better name than what I'm calling it. But the last row, it would be nice if that could reference a variable something that matched something. Okay, you know what? We're going to try it. I think I did this on the last time and it didn't like it. But we're going to find out. So A, B, C, D. Output. Okay, equals let A equals some crazy number, B equals 50. I'm being so silly about this. That's okay. C equals B plus A. D equals C plus B plus A. So I'm also not documenting this well. That's so silly of me. Let's just do that because then it's easier to read. I think my brain is literally falling out of my head. Okay, and then output A times, we don't need that. Our output, let's just say I want to just do A. And then I want to say, let's do this. Variable output equals insert. Let's just do a little drop down. Let's do a little drop down ski. I don't think this is going to work because I think I tried this last time and it was like, knock it off. A, B, C, D. We don't need that. Okay, variable is, let's say B. And then if I have that equal this. Oops. Oh, I'm an idiot. Wait, equals text of that? No, I knew that wasn't going to work. It felt like it should. See, it would have been nice if it was like, if I could say, oh, I want to get this calculation or that calculation or whatever, without having to go in and toggle that. But yes, if you were to say, damn, I knew there was something wrong with that. Okay. Cool. I'm still stalling. I just need to. I think the thing about lambdas is, like Eric said at the beginning, a lambda without a very well-built function underneath it is just a shitty lambda. That's not what he said. But he's like, what's a function to you? So like, the better I build functions, I think my problem is I don't notice that I'm repeating a formula over and over and over again until much later. I'm really trying to think through, like, I think I just need to keep watching good examples of lambdas to like invoke creativity, because I'm at a loss.
Arguments. Copy that. And come up here. Actually, sorry, I've already done this. So I've made this into a lambda called next player. So now I can just say next player of that starting player and that vector. And now it's all doing all the same thing. But now it's just kind of neatly packaged up. So my formula is super simple. Obviously.
My thing about players that are like Excel, like competitive Excel users that are like, are there people making lambdas on the fly, or is it because I feel like it's almost like an extreme step to take while you're, unless you're like very wicked at lambdas, which a lot of them are. I feel like the lambda step of it all is kind of, it's not a waste, but it's built on the logic inside. And so anyone who, dare I say, raw dogs right into a let or a lambda, it feels like you have to have so many repetitions of building them that it's kind of similar. Like if you had no idea XLOOKUP or SUMIFs, the criteria logic might feel overwhelming. And yes, Excel, Lambda Robot is about to change my life, and I'm really trying to push the fundamentals of like learning the beginning, end, and middle of all of this is that I need to make really good logical based formulas for that all to come together.
It requires a degree of kind of trust and the lambda, or you have to kind of pre-analyze the lambda before you can look at this formula and feel comfortable. But that lets you kind of package that up quite nicely, and then you can take it, put it down here, and
some creative recursive lambdas. I like the idea of the recursive to look for all opportunities. Ooh, scary. Harry mentioned when I have practiced a lot, just before a case, I get quite likely to use a let in that case. Okay, vibes. I feel like lets are a really good way of like the quick debug, and then also being able to write out logically, okay, I want this thing to happen and it might be used in the next one, especially for stacking logic from level to level. Because a lot of the times you use the same logic, and it's nice to be able to add or subtract or tweak one of the steps without having to bring over all of your helper columns. I think I need to, I forgot. There are lambda functions. I think it's like scan, map, others. I'm excited to use those because I've been afraid of them this far. But now I'm going to get in. Amber, what is a function? Not a trick question. Oh, I mean like an equation that has variables. What is a function? Okay. Okay, yeah. Things that have in it feels like a trick question. It's just an equation that needs variables. Oh man. Let's see what she's got going on.
Enables us to write custom functions that handle recursion. Now, recursion is simply when a routine calls itself. I say simply, but it can be a bit mind-bending. So in this video, we'll look at an example that's easy to follow. Once you understand the structure of the function, you can apply it to more complex tasks. Now remember, the Lambda function is currently only available in the Microsoft 365 beta channel, so you may not have it in your version of Microsoft 365 yet. A common example used to explain recursion is the factorial function. Now, a factorial function multiplies all whole numbers from a chosen number down to 1. For example, if our chosen number was 5, the formula would be 5 times 4 times 3 times 2 times 1, which gives us 120. Now, there is already a factorial function called fact, so we would never write our own lambda for this calculation, but this is a good way to demonstrate recursion, so go with me. By definition, a factorial function can be written as our chosen number, which I'll call n, times factorial n minus 1. In other words, the result of factorial n can be calculated as n multiplied by the result of factorial n minus 1, and the call for n minus 1 can recursively descend lower and lower till 1.
Since we have a good lot of hypergeniuses in the chat, if you guys would like to either submit your favorite use of a lambda or a let statement that you've used in your professional Excel, whatever, most impressive, exciting, creative use, feel free.
I'm going to call my factorial function factorial just to differentiate it from the existing fact function. And I'll just type it in this cell so we can keep it in mind while we write the lambda. Starting with lambda. Now I've only got one
Also, side note, guys, what should I get for dinner? I'm starving.
variable, which is the number I want to find the factorial of, called n. A key component of writing recursive lambdas is to provide it with an opportunity to bail out of that recursive loop. And the bailout is always written first, so I'm going to do this with if. First of all, I'm going to alt enter just to go down onto the next line, so the formula is easier to read. So our logical test is if n is less than 2, then we just want to return 1. That means the formula can stop evaluating here without moving on to that recursive part. Otherwise, we add the recursion that says, take n times factorial of n minus 1, close parentheses on if and my lambda. Now it's this reference to itself that can be super confusing, and it also prevents us being able to evaluate the function in a cell because the name factorial hasn't been defined yet. With non-recursive lambdas, you can enter the variable values at the end inside parentheses to evaluate the formula in the cell. But if we do this with recursive lambdas, we get an error because the name of the function is being referenced in the formula before it's being defined as a name. In last week's video, I had a simple lambda that had two variables, x and y, and the formula was simply x plus y. And then I could enter in my two variable values. In that example, I used 2 and 3. Placing them in parentheses at the end of my lambda allows me to evaluate it in the cell. But with recursive lambdas, we must define the lambda in the name manager.
X lookup largest, which is an X lookup with the item for an item with the largest from a set of values, max by, min by. Julian has a good one. It's just mod, but starting at 1 instead of 0. Ooh.
So let's get rid of the value that we entered at the end. I'm just going to copy the formula, and then we'll define a name for it. We're going to call it factorial, which it's picked up from this cell here, so that's Sabian.
Oh.
Paste it into the prefers to.
Of course, the unpivot. Award-winning unpivot, if we're being honest.
Click OK. Now in here, let's delete that. I can call my formula. There it is there. And I can give it the value, and it evaluates. And naming lambdas is fine if it works first time, like this did. But if you don't get the desired result, then toing and froing between the name manager, the troubleshoot is tedious. Hopefully the Excel team will come up with a better tool for authoring lambdas soon. In the meantime, the suggestion from Microsoft is to use let and a me parameter. So let's take a look at that. First of all, I'm going to go into the name manager and just delete that one, because we want to show the effect of typing in a new lambda function in a cell and being able to test it when it has recursion. Using the factorial example, we can replace the recursive call to factorial with me, passing in me as the first parameter and n as the second. Now factorial is a lambda with two parameters, me and n, and therefore we call factorial with two parameters, factorial and the value for n. The me parameter makes this possible by passing factorial as a parameter to itself, allowing it to then use that parameter to call itself. Once you're happy your lambda is returning the correct result, you can remove the first me parameter and replace the me with the lambda name that you want to use. So here we can get rid of all of this, get rid of the first me parameter, and instead of me here we'd have factorial. We wouldn't need the me in here, nor would we need any of this bit. And that would be our lambda. Of course this is going to return an error, so just copy this and then define the name. Paste in the refers to, our formula, and now we can use it.
See, this video is where it starts hurting my feelings. And I'm so close to getting it. So close. My busted ass fingers. I need to paint them. So close to getting it. Like I'm with her. And then like my brain just goes, and should I be applying this as we're doing it? Yes, I should. Man, I'm just mentally, I think it's the active practice of being bad at things. And I think I just need to do like the muscle memory of like doing them. And logically, it's not a difficult thing. I think it's just I think recursive logic is really where I'm going to unlock a lot of potential, especially with what I do, because there's a lot of variable time durations and there's a lot of good uses. But okay. Eric, honestly, thank you for saying that. I'm glad that I'm not the only one that recursive lambdas are starting out a little stressful. You know what? Next week, that's when I'm going to bring it back with, yes. Okay. Next week, I'm going to have very specific sets of goals. This week was just to open my eyes to what's going on in Lambda land, which honestly makes me feel good that Lambda is really function creation. And I do like that you can leave yourself hints on what the variables need to be, which is nice. Because I was also confused. I was like, oh, if everyone writes these how do they know what to put in the formula if they don't know? But you do. You can just leave yourself notes. And that's especially why the documentation is so important. Okay. Reading back through the comments. For dinner, I should have apples dipped in chocolate if I had those. Or it's May Day in UK, so you should dance around with a maypole with a cult and then... Okay. Perhaps I shall not be participating in May Day. Amber, Google's May Day. Ice cream and sweets are a good option too. Within cell syntax for recursive lambdas is kind of terrible and hard to learn and read. Okay. Thank you guys for making me feel better about that, because I was getting a little stressed. Okay. Lambdas are just functions for defining functions. Lets are used for variable declaration. Lambdas are for function declaration and creation. Together can be used for pure evil science. I think these two don't stress me out, but make me so uncomfortable because I love playing within the as loony bins as I seem. I love playing within the confines of a system that is built and learning all the intricacies of that system. So this is really the peak of the mountain for me. And I think as I take active approach, that's the whole point of Office Hours with Amber, is doing scary things and being bad at them and getting a little better, being able to be literate in this stuff. So eventually I could be a little better. I think I will be very proud of myself if I can really back in January, did dynamic arrays. If I can do like map scan, go back through and find all of the Lambda based dynamic array functions, understand their utility as a stepping stone into my own Lambda creations, and then try to, I would wonder if this only saves time in the creation of my data table, like in the creation of my Excel tools, or if there's some computational efficiencies as well. Chat if you know. I feel like you would, but if not, no worries. At least it would be simplified on the page and like less likely for people to mess with it because they wouldn't be able to really do much with it. Thank you. I think I am brave for facing my phobia as well, because it's been a long time coming, and I think is the biggest differentiator between me and most of the competitive Excel community right now is everyone can spit lambdas so fast, and I'm like, oh, and then I just exit the conversation. So the nice thing is I'm excited for the WhatsApp group, the Lambda Land, so that I can go back through and find all the good ones, because there are some goodies in there. But okay, I digress. I'm gonna go get some dinner, but I'll probably hang out in the chit chat chamber for a little bit, waiting for, I can't even get dinner because my car's not here. My life is so hard. Anyways, next week I will be implementing lambdas on a tool. It's gonna be great. Thank you guys for coming. I can't believe the number of strokes I had in the last hour. Okay, I'll see you guys in the chit chat chamber. Again, no idea when this goes off. I need like an exit video. Like a thanks for coming, and then it's got like a little cute. Okay, I think I've given everyone enough time. Bye.